Pei, do you know what he's saying? Can you ask him?
Yeah, just put it there.
Ah, okay. Thank you. Good morning.
Good morning, teacher.
Okay, so what I'd like to present here is more of a sample scenario to evoke a discussion and also to give me an opportunity to ask some questions that I have that I didn't have the opportunity to ask in the last few days. Rather than being a full presentation of a solution, it's more of a discussion scenario. Essentially what I'm thinking here is we would use the simulation framework that's been outlined in the past few days by Ben and Lake in the Unity3D graphical simulation environment, along with the Moses automated program evolution module that's within OpenCog in order to control the robot agent to perform certain actions that I'll describe in a moment, along with the attention allocation and the OpenPsi motivation modulation, and potentially some simple logical inference steps. Many of you are probably already familiar with this particular problem called the Santa Fe Trail problem, but I'll briefly cover it anyways. Essentially, you have this two-dimensional grid with food pellets arranged in a particular pattern, and this pattern is meant to present a somewhat structured but difficult challenge in which you would use this as a benchmark to evolve an agent, often using genetic programming strategies, in order to create an agent that is able to efficiently consume all the food pellets within a constrained amount of time. Moshe Lux, who developed the Moses algorithm, used this as one of his test scenarios in his PhD thesis to evaluate the performance of Moses against other previously known algorithms. Now, what I was thinking is we could use this similar problem to evaluate multiple components of the OpenCog framework together and see how they work together. Particularly, we could use the Unity3D game world with an arrangement of battery blocks inside the game world, and then use Moses to develop a control strategy for the robot to navigate the world and consume these blocks. And we need to think of a way to measure the fitness of the robot in that particular scenario. And in this case, we have the OpenPsi demand regulation, where it presents the robot's attributes such as energy and integrity. And a potential fitness function would be how well these attributes were regulated by the control strategy while it was consuming these modules. So I'll show you an illustration here. Seems Ben has left. So for example, here's the simulation world, and you could construct the trail for the Santa Fe ant trail problem out of these battery blocks that you see in purple. So you'd construct the pattern in the world using these battery blocks. Potentially, you could introduce additional complexity or distractions for the agent, such as these mushrooms that are placed here. So Ben, I was just explaining how we might use the same problem that Moshe Lux used, but put it into the Unity world.
Yeah, I understood that
Okay.
from your abstract.
Very good. So potentially what we would do is we would need to use Moses to evolve candidate control programs, and then each candidate needs to be evaluated in the simulation to determine how it performs in order to continue evolving the candidates to find a near optimal solution. Running it in this graphical simulator is likely to be somewhat slow. However, Lake pointed out to me that there is an option to use this particular simulation engine in what's called a headless mode, so that you could run simulations faster without rendering the graphics. It is yet to be determined how fast or efficient that might prove to be. One of the questions that I'm thinking about that I'd like to discuss is when you're running internal simulations in order to develop a control strategy to use in an actual environment, how well should you model that environment inside your mind? And more specifically, if there's other intelligent agents in that environment, how can you best develop an internal model of the expected behavior of those agents in order to effectively evolve a control strategy without knowing perfectly how those other agents are going to respond to you? So as I mentioned, you could potentially add additional complexity to the environment, perhaps in the form of mushrooms or things that are coming up to potentially pose harm to your agent, or other scenarios that you could come up with. So one thing that I'd like to discuss in a moment is how the attention allocation algorithm would help you in a more complex environment in which you're presented with lots of distractions, and yet you also have one or several particular objectives that you're attempting to pursue. And I'd also like to ask for more clarification and discussion around what is the dynamic between the OpenPsi system and the economic attention allocation system, because they both seem to be influencing the agents.
Goal nodes pump out short-term importance.
Can you elaborate on that?
No. Yeah, of course. No. Well, so the central bank, which is in effect the COG server, it collects STI from the rent paid by atoms during the action of the importance update or remind agent. And one of the things it does with that importance that it has collected is it allows goal nodes to send short-term importance to those atoms such that there's an implication link where the causing of a certain predicate to hold implies this goal being satisfied. So in that case, importance will spread to the atom whose fulfillment would cause the goal to be satisfied. So that would be the simplest mechanism, which has already been used in the system before. Like if you have a goal G and you have P implies G, then depending on how important the goal G is to the system, the central bank will direct some STI to P, basically. Now, that's a simplistic kind of mechanism, which is probably fine for something like the artificial ant problem. Now, in the OpenCog book, a more complex mechanism is also outlined, which I think will be needed for more subtle goal-oriented behavior, where you have, rather than just the goal node sending out short-term importance, the goal node sends out more complex tokens, which are like, we call them RFPs, like requests for proposals. So like the goal node, if you have P implies G, where G is a goal, then the goal node may send P basically a promissory note saying, if you get fulfilled, then I'll give you this amount of short-term importance. And then those can also be propagated. And that mechanism has been described theoretically and analyzed a bit, but has never been implemented. I don't think that's needed for this case, which is relatively simple. When the goals become complicated enough, particularly involving multiple sub-goals on multiple different time scales, is when I think you would need a mechanism like that. Like when you have a goal that requires you to, think in one way over a year, or maybe not even a year, think in one way over 2 hours, and another way over 10 minutes, and another way over 30 seconds, where there may be apparent conflicts between what you're doing in the shorter term and what you're doing in the longer term. If that kind of conflict between your sub-goals on different time scales is tricky, then I think just having the goals pump out STI is not going to be enough, and you need this more complex mechanism. But I doubt you would need it for the more straightforward incarnations of the artificial ant problem. Like in my own speculation, I think like a dog probably doesn't have a very complex mechanism like that. I mean, dogs aren't that good at balancing multiple goals and multitasking at one point in time, right? They can sub-goal, but they don't juggle like 20 different sub-goals as a mentally adept human can do.
How does the OpenPsi regulation interact with the short-term importance spreading?
Well, OpenPsi it chooses actions in order to cause goals to be achieved. But how does it choose actions? It uses the importance values. So this importance dynamics is kind of the infrastructure that allows OpenPsi action selection to make any sense, basically. I mean, OpenPsi's action selection is guided by various modulators, which are just parameters of the process. But ultimately, it boils down to, which goals are more important. And of all the actions that would lead to each of those goals, which of those actions has a higher strength implication to that goal, and which of those actions has a higher short-term importance. So we need that attention allocation for OpenPsi to make action selection choices in a contextually guided way rather than just based on a default.
Mm-hmm. So some potential additions, as I mentioned, is you could go beyond the basic artificial ant problem and you could add additional complexity to the world. For example, you might have the robot navigating the environment. In addition to consuming battery nodes, he finds that he's also interested in consuming red mushroom nodes, but the brown mushrooms are actually bad for him. So he might need to use some more complex strategies to learn and adapt to this. It might be an opportunity to use simple PLM deduction and also Hebbian associations if, for example, the mushrooms tend to grow in the vicinity of the batteries. He could form that association in the atom space and also use a simple deduction rule to create a conjecture that creates an implication link between the two, although not certain. Yes, Pei.
Yeah, I have a question about the overall setting of the problem.
Mm-hmm.
It seems that this Santa Fe trail problem, by definition, is a two-dimensional search problem. Now you suggest a three-dimensional simulation. I wonder, of course it looks cool, interesting, but the third dimension, does that change the problem in any way? Do you allow the robot to see at a certain distance or from the sky? Why you want to really add a third dimension into the problem?
Why do I want to add, or is that what you said?
Yeah, why you represent the problem in a 3D simulation environment,
Sure.
rather than just stay with a two-dimensional representation, which is much easier.
Ultimately, I'd like to be able to run complex, multi-agent simulations inside the dynamic Unity world that have lots of complexity. But I thought a simpler starting point to run such simulations would be to choose a simpler problem that's been studied before and bring it out of the non-graphical simulation and put it into the Unity simulation. It's not really taking advantage of the three-dimensional world.
Okay. Then my question will be, maybe you can still solve the problem, just use a pure two-dimensional solution, then just add a dimension just for display purpose, right? When you do problem solving, you do genetic programming. Do you really need to take the third dimension into consideration?
The thing is, for Moses and OpenCog, it's not particularly more difficult to take the third dimension into consideration. It's already there in the framework. So
yeah, does that change the problem in any way?
Well, I mean, it doesn't change the...
So for example, when you search for a house, you still do it on two dimension, right? You don't think about if I jump over.
You want to answer? I mean,
okay.
It depends on the complexity of the 3D environment, really. I mean, no, if he uses the existing primitives that are supplied with OpenCog, I mean, if you notice a certain object and say go to that object, then there's already a primitive in OpenCog that would go to that object two-dimensionally or three-dimensionally. And if some of the food is up on top of something and you ask PLN to get up on top of that thing, PLN knows how to build stairs because it inferred that before to get up on top of it. So you could run it in a pure 2D scenario with nothing rising up high, and then the primitives will default to simple 2D movement, just like we would if we were in a flat plane with nothing to climb on. Then even though we have 3D capability, we would default to moving in 2 dimensions because there's nothing else to do. On the other hand, adding the third dimension in the context of the specific world we have now also adds more avenues for Moses to interact with PLN and planning and so on. You could do that in 2 dimensions. You could build mazes and complex things in 2 dimensions for it to solve. But by building 3-dimensional structures, there's a lot of kind of immediate and easy inference problems there, which happen to be the kind of things we've worked on before with PLN and with various planning algorithms. So I think in the context of the existing non-Moses tools within OpenCog as they exist at this moment, a 3D world is a good avenue to experiment with the interaction of Moses with PLN and with planning, because we've already experimented on various 3D problems there. Now that's no longer the classic Santa Fe trail problem. But we already know that Moses can solve the classic Santa Fe trail problems. I mean, Moshe did that in his PhD thesis in 2006. So showing that Moses can solve the Santa Fe trail problem with blocks doesn't matter, right? I mean, that's just a different graphical interface to what Moshe did in 2006 and wouldn't really have any value, but to make a pretty picture on an already known research result. So I think the reason I thought this was a good idea is because it lets Cosmo get up and running with using Moses in an integrated OpenCog context on a problem where we already know Moses works. So it's been tuned to work already. So he's unlikely to run into a bad problem of, oh shit, now I have to improve Moses, right? Because Moses already does this problem. And then, I mean, as you make the problem harder, we don't know if we can still do it. But at least Moses is known to do the base case already.
So, Lake, I was just describing setting up some sort of problem like this in the world. And what I'd like to discuss now, and maybe get your feedback, is how accurate should agent's internal simulation engine be? Because potentially we have the opportunity to use the full Unity simulation environment in a headless mode to run internal simulations in order to choose the strategy that you're going to execute in the actual simulation. Or you could attempt to create a much simpler internal simulation environment. You could even simply use a two-dimensional array in your head and run through strategies there. However, that probably won't be sufficient once you evolve this type of scenario into something more complex, where you start to have other agents interacting with you and other stimuli in the environment.
Yeah, I think there's a number of issues here. So one, of course, is just what is the actual speed of the headless Unity3D versus, say, using OpenCog's internal 3D space map and building a lightweight simulator on top of that. I mean, if it's 5 times slower, that's one thing. If it's 100 times slower, then you would get by hacking something specialized. That's another thing. But besides that, there's also the question of whether an accurate simulation is always what you want. Now, probably for something like the artificial ant problem, an accurate simulation, it is what you want, right? So it's purely a question of whether the headless Unity3D is too slow to serve as a good fitness estimator. So then you just need to make a simpler simulator on top of the 3D space map, so it's all C++ running in the same process as the atom space and everything else. On the other hand, for more complex kinds of problems, you may have a different situation where doing accurate physics simulation of movements is not really what you want, and you want some kind of more abstracted, higher level internal simulation, which a game engine might not even be the best avenue for. I mean, sometimes we can simulate situations in a much more abstracted way in our minds, which still requires keeping basic track of spatial relationships and physical movements, but doesn't require calculating everything by the laws of physics.
Mm-hmm.
And when you reach that case, I don't know either, but I mean, the artificial ant problem obviously is so tied to the specific geometry and the specific objects in a space. Clearly, the more accurate, the better.
I think from a practical standpoint, for like if this project was going to start in the near future, I would lean more towards building it in Unity in a headless mode, just because if we're going to
fit in here.
On a less practical note, there's been some discussion on the team for a while about how much information, like how accurate perception of the world that we want to give. Right now, we're having it perceive all blocks.
Yeah.
We had some discussion of having a field of view and only blocks within the field of view
Right.
being streamed to OpenCog. We haven't really tested any of that yet, but I think that that's promising both as a way to minimize like the number of blocks that we have to deal with, like in the perception action interface and other places. But if you can actually build a good reasoning process based on like very limited data like that, then that would also be really useful.
Yeah, more realistic.
Yeah, that too. I mean, you'd probably remember certain key blocks and their relationships, but ignore most. I guess it just depends on how much block streaming you want to do. It could be that we come up with a good solution to be streaming all the blocks into the atom space all the time, and it perceives the whole world, but it only remembers very small bits of it, like a normal person would if they were naively running around.
So the next topic to discuss would be, imagine you have a more complex simulation in which you have 2 AGI agents and 1 human agent, and your job is to control one of those AGI agents. How accurate and how should you build an internal model of the expected behavior of the other AGI and the human in order to anticipate their behaviors while you're attempting to pursue your goals? Anyone have thoughts on that?
Well, the simplest way, I mean, take a step back and look at how people make theory of mind, there's really two different aspects to it. One is a sort of inferential aspect, and the other is more of an empathic aspect, which is based more on simulation modeling. Now, I think the most straightforward way to start with modeling others in an OpenCog context is the inferential way, where you're just, you're recording data about what the other guy did, and then that data is declarative knowledge stored in the atom space, and you can then draw inferential conclusions using PLN about what the other guy did. Now that's limited, but it has some value. Now you could, in a simple context, like an artificial ant problem, you could actually do a simulation approach by using Moses to try to learn a small program that will emulate what the other guy does. So you're evolving a program, and the fitness of the program is how well would it have emulated the other guy's actions in the world, given the situations that the other guy was in. So the input to the program is a sub-world state representing the surround of some guy and the state of the world in some way. And the output is the actions that the other guy was observed to take. So then what Moses would evolve would be a program tree that was a very crude model of the other guy. So, I mean, you could see, like, let's say you're in a bar at night and some girl keeps following you around. You may not need to model everything that happens in that girl's mind. You have a very simple Moses program, which is, when I walk here, the girl walks close to me, and you keep going. So that may not be a total model of that agent, but it may suffice to model the behavior in a certain context. I mean, you can see that working in a robot soccer context as well, for example. You'd be just remodeling the behavioral propensities of that other agent in given context. That could work in a bunch of different game contexts. You're kind of inferring the behavior tree and perhaps a behavior graph, not necessarily a simplistic behavior tree, but you're inferring the decision structure underlying that agent's behavior. So that's like the poor man's way to do simulation of other agents, which is an interesting Moses application. And along the lines of the virtual pet learning we did before, because there we were trying to learn a program tree that would emulate what some other character does when they were playing fetch or follow the leader or some specific game. So that this is just like that, but you're trying to emulate the other character doing a host of different behaviors with one composite program, which could well end up being a behavior with a program with little modules corresponding to, like, sometimes this character plays fetch, sometimes they play follow the leader, sometimes they chase me and whatnot. Now those are both fairly straightforward things to do. The subtler thing to do, which is more interesting and is certainly needed in the long run, is like real empathic internal simulation modeling of another mind, where you then try to figure out in your mind's eye, like, what is the other person thinking? Why are they doing what they're doing? And OpenCog architecture likely supports this. There would be a lot of different ways to do it. I mean, one way you could do it, which is probably not that difficult on the implementation level, but it is a big thing to try anyway. It's like you could make a whole other atom space for each guy you're trying to simulate. So I could have in my own cloud server like a Cosmo atom space, which is basically contains my estimation of what you know and what you know how to do and what you believe and so forth. Now, of course, it doesn't have to be its own atom space, because you could use hypothetical links to store all those beliefs in your own standard atom space. But thinking of it as a separate atom space, even if it's not implemented that way, it kind of makes things clear. Like you're trying to have a whole emulation of the knowledge base of this other
That's interesting.
this other guy. So if you had a distributed OpenCog scenario, you could like put that on its own machine. Like here's, if everyone I know, here's my internal Cosmo machine, here's my internal Lake machine, here's my internal Pei Wang machine that reasons using NARS instead of probability theory. And then you'd have all these separate machines, and then you could actually test what this other machine does in different scenarios. And that doesn't seem fundamentally problematic, but obviously that would lead to a long list of other tricky little things to change and do in order to implement it. But this underlies my broader idea that ultimately AGIs, if they're not architected in close imitation of the human mind, could be more rather than less empathic than human beings. Because I'm not that good at recording like everything you believe and you think and all your behavior patterns, even if I've observed you a lot. I mean, maybe that's just because I'm a nerd and not oriented to other people, but I think most people have a limited capability of that, whereas an AGI could actually maintain a whole, like, mini Cosmo, mini Lake, and so forth as best it could, and then compare its behavior in simulation environments to what the real guy did. Which, of course, that doesn't imply empathy, because you could use that knowledge just to figure out how to best torture all these other people. But it would make empathy easier if the system were empathically oriented.
Any other thoughts on either to what extent you should model the world in your internal simulation and how you should model other agents?
I may come out. Philosophically speaking, I prefer the second route map suggested by Ben. You should have some inner model of other people, but maybe it would be too complicated to model in the model of this guy, that guy. I think there should be a simpler way. You have a default assumption. Default assumption is other minds are analogical to my mind. So I just suppose Cosmo, your thinking should be somehow similar to me. So this is the default thinking, default assumption. But I will observe your behavior, okay? Find that in this aspect or that aspect, you might be different from my output or behavior. So observations can help in revising the original parameters of the inner model of others. So in this way, I can just establish one prototype model and make the observations of other individual people behaviors as the resources for make revisions. That would be simpler.
Okay. So because of the cost of simulating every single potential candidate solution, it might be a good idea to use fitness approximation to reduce the scope of candidates that you actually have to run in the full simulation environment. I'd like to ask any particular thoughts about how that could be integrated.
Well, I mean, using fitness estimation inside Moses, I mean, that's been done before, and that's not difficult on the code level.
Mm-hmm.
I mean, the question is just how are you doing the estimation, and you can have multiple different levels of fitness estimation also. So I mean, if something's very expensive, I mean, potentially getting back to the two simulation worlds idea we were talking about, if the headless Unity world is really expensive, you could use a very simple simulation inside the 3D space map just to rule out really dumb programs. Like say a Moses program that doesn't move at all, right? Or a Moses program that ends up in a completely different region of the world than all the food. And one that causes the agent to kill itself by shooting itself in the head or something. And then those could be ruled out by a world simulation that doesn't have anything subtle in it at all. Then if anything passes that test, then it goes next to the headless Unity3D world. And if it passes that test, then it goes to the real Unity world. And even, so that's certainly one possibility. You know, that there could also be, I mean, if it's probably too complex for this case, but there would be ways to do fitness estimation that didn't involve any simulation world at all. In fact, I mean, you could take the program tree and you can calculate the execution trace or propagating some of the input variables through that execution trace as variables, much as you do when, say, super compiling a program. And then you can compare that execution trace to the execution traces of other successful and unsuccessful programs. And if the execution trace with the input still represented as variables, if that execution trace resembled the bad execution traces rather than the good ones, then you don't even try it, even in the cheap simulation world.
Wouldn't you still need to represent the program in some elegant normal form for that, so that they're comparable?
Yeah, you need to normalize, but all programs in Moses are normalized.
Okay.
You need to normalize the program, and you would also need to write code that doesn't now exist for representing the execution trace of a combo program with the inputs potentially represented as variables and propagated through. So you'd have to basically do the hard part of making a super compiler for combo, which is not that hard because combo is a very simple language. So you understand what I mean by execution, by propagating the variable values through. You don't bind the input variable. So if you had an input variable v1 and a conditional somewhere, then you just have to, when you're making the execution trace of the program, it like splits in two, right? There's one possibility, well, if v1 was greater than 0.5, another if v1 was less than 0.5. So the execution trace actually becomes a kind of branching DAG of execution traces. But in theory, from that, you could compare it and say, well, you know, none of the execution traces of good programs look like this. All of the execution traces of bad programs look like this. So it's probably not even worth trying this. So that's kind of like thinking through in your mind's eye what kind of thing would happen if I did this without bothering with the spatial visualization. You know, in the artificial ant case, that's certainly overkill because this is a simple problem that Moses was able to solve long ago. If you're learning something where Moses has to learn programs involving recursion or local variables or something, then this sort of thing may well be useful because then the search space is much larger and the potential for generation of gibberish programs is larger. But in those cases, for the probabilistic modeling inside Moses, you probably want to use modeling of the execution traces anyway. So it wouldn't be only for fitness estimation. If that work were done, it could be used in the core Moses algorithm as well.
Sounds like interesting research.
Yeah, what I will say is much more simplistic, but I think if you do the simulation, I assume that the normal fitness approximation would be just count the number of food pellets that your program expects to get. And I think you should probably take into account if the world is dynamic or stochastic or partially observable, that maybe you want to weigh closer pellets higher because you might be more sure that you can actually get them.
Okay. And what if you add in the OpenPsi demands into your scenario so that you're not just trying to eat the pellets, but you're also trying to do it in the context of satisfying your need for the energy from the pellets, but also your need, for example, for integrity from going back to your home area.
So that just means you have other goals besides solving the artificial ant problem, right?
Yeah.
I mean, you're solving under an additional constraint, like you don't want to get too far away from home for too long or something, right? So then, yeah, then you're going to solve the artificial ant problem more slowly and maybe according to a different pattern, depending on where your house is relative to the pellets.
Right.
You can look into multi-objective genetic algorithms for that type
Uh-huh.
of thing. Yeah.
Sure, thanks.
Yeah, if you wanted to do, we've not done Moses in a multi-objective way so far. I mean, we've just, we've weighted, we've had an objective function that weights multiple subcomponents, but we haven't done true multi-objective optimization. But you certainly could, and if you wanted to go in that direction, one simple thing to do, which requires some tweaking inside Moses, would be you would start with several different objective functions, and the different deems in Moses, as well as having different feature sets, could have different relative weightings to the different sub-objective functions. So you could have one deem that weighted security twice as much as energy, another deem that weighted energy twice as much as security, and so forth. So then you'd be exploring the weight space, the weight vector space, along with the feature space and the program space, and then that probably would be a good way to deal with it, because for things as complicated as this, most of the simpler methods in multi-objective optimization won't work anyway. So you're going to end up just searching through the good weightings of the different objective functions, co-evolving them with the feature set and the actual program. Again, is almost surely not needed for the artificial ant problem. But doesn't mean the artificial ant problem couldn't be an interesting context in which to explore the idea either.
Sure. One sec. I guess next I'd just like to get feedback from Chris and Eric on this sort of context for a problem and what you think of the approach we've discussed so far, and if you have some completely alternate approaches you might suggest.
Can you state the goal again?
Sure. The goal is to use an embodied agent in a simulated three-dimensional environment with potentially more complex situations where he might have this sort of food pathfinding but also interaction with other intelligent agents, and he needs to solve problems in that environment.
Right, but the AGI goal is what?
To achieve multiple objectives in a simulated three-dimensional environment.
I'm a bit concerned by the approach that you take,
Okay.
which, if I understand it clearly enough, is to divide and conquer. You state the problem, you run simulation in your head, and then you will quickly come up with the question, yeah, but I should simulate also the behavior of the others. So, to get back to the crux of what I think might probably solve the problem is, how good would be a program learned, or evolved if you like Moses, when you put it back in the real world, and everybody else is trying to make you fail. What would you have learned in the end? In a vacuum like this, wouldn't you think instead it might be, well, at least an option, just to learn everything breadth first on the fly? Because to solve a maze is one thing, but should the maze move, should the mushroom start to get a little bit hallucinogenic, what would be the value of the so-called program evolution? You know? you can estimate the fitness and whatever, but this changes all the time. So I feel there might, well, I'm very uncomfortable with the idea of freezing things, you know, and learning by whichever technical means is of no importance to me. But I mean, principle, what do you get by freezing things?
Interestingly, it would seem that by evolving a Moses program that calls the existing primitives that we have in OpenCog, it seems like you would already get a program that is robust with respect to those kinds of changes. Because if you, as an example, if you see some object and your Moses program calls the primitive go-to-object, right? The go-to-object primitive already can deal with dynamics, moving things in OpenCog. Therefore, the program will be robust with respect to that. Just like if I call in my mind, go to Cosmo's laptop, and then there's someone standing in the way, I have a lower level program that knows how to go around the guy who's standing in the way, so that the combo programs Moses would learn would inherit some robustness just from the robustness of the primitives it calls. But I mean, in the end, of course, the artificial ant problem is a toy problem, right? So I mean, which he chose because it's a toy problem that genetic programming has been used for many times. So then it inherits the strengths and weaknesses of all toy problems, right? I mean,
of course, but still, whatever the technical means, in fact, what he's trying to do is to compress the world, actually, and compress the behaviors of others. Okay, but in order to do that, we know that the higher, the more general the concepts that you start with, the better the compression. The question is, how do you get there in the first place?
yeah, well, I think if the program's only goal is to solve the artificial ant problem, it's not going to achieve any highly abstract
For sure,
models of the world,
right.
because that's a pretty simple problem. You don't need you don't need an abstract representation to solve it particularly. So actually, I guess you could look at this project from multiple standpoints, really. One question is it a good scientific research project? And I don't think it is. I don't think it was intended as such. The other is it a good project for engineering, for Cosmo to test integration of various OpenCog components that haven't been used together before, and I think it's good from that standpoint. But if it were like a research proposal for an undergraduate thesis or a master's thesis or something, then I'd say, well, you need to state the research question you're trying to answer, and how does this resolve that research question. But I don't think it is being. I don't think it's being posed that way. I think to run my mental simulation of Cosmo, I think one of his goals is just to understand how to work with OpenCog in a way that will let him touch a whole bunch of different OpenCog components in some simple context. And then this does that. So, someone's following me?
I'm also curious, not on a slightly different context, what it would look like to use the era architecture to control agents in simulated 3D environments like the game worlds that have been presented the last few days.
Oh, I don't know, there is no technical challenge in there. It can be a word like this, or like that. It doesn't matter at all, it's just a question of interfacing. So in principle, no problem. Maybe one thing that would not be the same is the way the machine learns. In our system, we learn things always on the fly, and we observe things. So a machine, for example, when in our case, wouldn't be able to learn anything in vacuum. Yeah? It needs some example. It needs something more intelligent than it is to observe and grab things of interest. It's more, if you'd like, a social thing. It's less thinker in his ivory tower being simulated or not. So I think the learning strategy and teaching strategy would not be the same. Because in fact we are obsessed with the real-time operation too. There is no evolving or no thing like that. So yes, of course, we would put some more stringent requirements on the world itself, especially in the observability thereof. But apart from that, yes, it can be done, sure. Not the same.
Thanks. Do you have any thoughts, Chris? Okay.
I have 2 questions.
Sure.
Actually, there are 2 questions research questions I would like to explore in your scenario. One is, what happens if you add, because actually you mentioned it, but I don't think you have elaborated on it. That is, you have the mushrooms there, which is not understood by the agent before. But then, what happens if you add an element of curiosity, like you said, that maybe in addition to looking for the energy, it will also try out the mushrooms there. And then maybe one type of these mushrooms will also give him a little bit of energy. And then it will learn from there, okay, these mushrooms are good for me too. Even though I didn't know it before, but now I'm adding it to my knowledge. And then I will, from now on, whenever I see these mushrooms, I will try them too. I will try to take them. And then you have these brown mushrooms, and then out of curiosity, we also try to taste it, and then he found, okay, no, this is no good. I'm having a diarrhea or whatever, and it lowers my energy or something. And then you add it to your knowledge, and then next time when you see it, you try to avoid it. Is this something that you were trying to do as well?
Yeah, I like the idea of starting the agent with almost no knowledge pre-programmed about its world and having it learn that through experience. And the potential to use curiosity seems to be a good idea as well.
Yeah, and then the other question I would like to explore is that you mentioned this, how an agent perceives the other agent. And also our classmate, he mentioned that you don't assume that the other agent will behave like you, which means that you don't, well, in the world of simulation, which means that you don't know the, say, if you're doing the search, you don't know the search algorithm of the other agent. So you're trying to maybe first try to project how that agent will behave using how you would behave in this world. But if it doesn't behave like you do, then you would try to learn the pattern of that agent. Then maybe you are using an A-star search, and then first you would try to evaluate whether that agent is doing an A-star search, and then if it's not, then you would try to learn. But maybe you don't have the knowledge of a depth-first search or breadth-first search. But is it possible to learn this algorithm from observing the behavior of that agent? Well, that is another question I would like to explore in this scenario.
Thanks. Yeah, so mostly this is just a proposal from an engineering perspective to try and fit together multiple subcomponents to get a better real-life understanding of how they work and how they potentially interact to produce some type of dynamic together. So any more comments?
I have a comment more about how, what you might do after that engineering achievement that would be more of an interesting research project would be, say you train a Moses model to to do the artificial ant problem, given certain constraints, then you change the nature of the problem a bit, either by changing the world or changing the goal or whatever. Then you ask, can you use PLN to generalize the programs learned by Moses based on declaratively given knowledge of the changes you've made to the world? And can that then inferentially guess new programs, right? So let's say that you, for example, you start out with a standard artificial ant problem, and you learn some Moses programs to solve them. Then you introduce a change, which is there's some of the food pellets are big and give a lot more energy, and some are small and give a lot less energy or something. So you introduce two different kinds of food pellets. Then what you would like is for the system to learn how to deal with the ant problem with two different kinds of food pellets without having to do a bunch more trial and error, as Moses would, but just by abstract PLN reasoning, that it would then learn to prioritize eating the big food pellet over the small food pellet, and would then take the learned Moses program trees from the first version of the artificial ant problem and tweak them based on its knowledge of the new situation to get a new, slightly different program tree. So that involves taking the combo program, exporting it to the atom space, doing some PLN reasoning based on it, then synthesizing a new combo program from the inferred sequential end links in the atom space. And then that becomes a modest size but interesting research project, because you're looking at the ability of probabilistic inference to generalize the rules learned by evolutionary learning. So it's sort of procedure learning generalized by declarative learning turned back into new procedures. That, of course, is a bit of extra work beyond what you described here, but probably the extra work to get that to be done is maybe a third the size of the work to get the stuff that you've described here already, depending on the state of PLN at the time that you get there.
Well, for what you described, would that basically require writing a new mind agent to do those connections, the tweaking of the combo trees with PLN, or is it just part of PLN?
PLN, well, it would require, in the current state, it would require adding more things to PLN. The old C++ PLN did that kind of reason.
Okay.
But Jade's Python PLN was never extended to sequential add links and the various links involved with action execution. So in the C++ PLN, we did stuff somewhat like that, where we took procedure knowledge, we generalized using PLN, and then we could synthesize new combo programs from basically traversing the atom space. So it would involve either resurrecting some of Ari's long decayed code or writing something new to do the same thing. So that the reasoning itself would just be plain vanilla PLN. The extra thing there that Ari wrote a long time ago that we haven't used for a while would be the declarative to procedural knowledge conversion. Like the thing that traversed the atom space, grabbed a little subtree based on sequential end links and whatnot, and spat out a combo tree to be executed. And that code is in some branch from a long time ago, and I'm not sure what limitations it has.
So after you performed logical inference to create this new combo program, would you then use the attributes of that program to run a more targeted Moses evolution, or would you already have what you needed?
You wouldn't necessarily need to do more Moses evolution. I mean, you could try the new program, and if it worked, that's great, right? I mean,
But potentially.
Potentially, yeah. I mean, for the specific case I outlined, probably PLN could just solve it. It's not very hard. On the other hand, if it was a little subtler and you had many different kinds of pellets, the different distributions or whatever, you would guess PLN could come up with the basic idea, but then to fine tune like the weights of how much you go over here to look for this pellet and how much you go over there to look for that pellet, fine tuning stuff like that is something evolutionary learning is better than reasoning at.
Right.
So then in that case, what you said would be the right approach.
Any more comments? Yes.
Yeah, I just wonder how you use Moses to handle multiple objectives. I raised the question because some of the players work on multiple objectives. To me, it's actually a more complicated fitness function. Okay, you have 3 goals, but if you can always do, say, a weighted average of these 3 goals, then you can see conceptually you actually only have 1 goal. It's just the fitness function is more complicated. To me, a truly multiple objective system is the one that it changes over time. Say you have 5 goals, but at a certain moment you only pursue 3 of them. In another moment you pursue the other 3. So the problem becomes the fitness function is actually different. So a high fitness program may become a low fitness program in a different scenario.
So how I think I answered that a few minutes ago. I mean, the way I would use Moses to handle multi-objective programming is, I mean, if you have, say, 5 different objectives and they're going to be balanced in different ways, Moses has many different deans, and each dean, so in the current version of Moses, each dean has a different subset of the overall feature space. Each dean could also have a different weighting of the different objectives. So you're exploring multiple different ways of weighting the different objective functions together.
So each scenario you have a different dean.
No, each scenario you have thousands of deans.
Okay.
And each dean has different weightings, the different fitness functions.
But
some deans will be more pertinent to some scenarios than to others.
Then how do you represent this information within each dean so that you know that this dean is good for that kind of thing? How can you recognize when to use which?
Well, you mean if some weightings of the different objectives are better for some context than others?
If you really have a multiple objective situation, you have to have somehow to have that information somehow represented in a program developed by genetic programming.
Do you have a specific example?
Well, it just, again, if you have 2 different scenarios, even if this are trail problem, you may have to, not only you have, say, 3 top candidate solution, okay, and also you need to remember that the number 1 candidate is work better for, say, there are a lot of rivers. And the number 1 and number 2 works better when you have to go uphill or something.
Why is that multi-objective? That's just a condition in the program, right? You say, if there are many rivers nearby, then this.
Yeah, that's sometimes you can.
You don't need to formulate that as a multi-objective program.
Yeah, sometimes you can turn that condition into some kind of objective. So, for example, you say you want to cross the smallest number of rivers possible.
Well, but then, if you have a program that says if there are many rivers present, then if I jump up and down 3 times, gold will fall from the sky or something. Then you may want to say, okay, how can I cause there to be many rivers present? So that kind of chaining of A implies B, B implies C, and so forth, we would be using PLN, not within Moses, generally speaking.
Okay.
But we wouldn't do that using multi-objective optimization.
Thanks for your time.
Yeah. Now let's begin now. Basically I'm not trained in the tradition of engineering. Okay, basically speaking, I'm a philosopher. But I found that AI is something very, very interesting from the philosophical perspective. So the title is From Turing to Confucius. People will ask Confucius lived in the spring and autumn. So according to the historical sequence, I should say from Confucius to Turing. But what I put Confucius last because not only because I'm Chinese, but also because I found that he is more interesting. Okay, he has a more philosophical significance. So The topic is natural language processing, but maybe I will also talk about something related to it. So now I need to have give you a big picture on the relationship between philosophy and AI. Okay, why philosophers are interested in AI? Because AI is something very special. AI is a special thing among other disciplines in the sense that it does not have a unified theoretical foundation as classical physics does. Okay, different AI approaches have different theoretical assumptions, but they all live in the same AI society. But you can hardly imagine that in mature physics, in biology, or in chemistry, scientists will have entirely different ideas about what biology should be done, how physics should be done. It's impossible, okay? So another thing is we can compare AI technology, the engineering stuff in AI, with biotechnology, okay? If you want to do biotechnology, you should do biology first. And philosophers cannot have direct influence on biotechnology. Okay, bioengineers should learn something from biology first, rather than from philosophy of biology. So this is a sandwich structure. The sandwich structure is on the top. We can see philosophy of biology. In the middle, we can see biology, then biotech. Okay. But in AI, we do not have the second layer because we have said that there is no well-accepted unified theory about intelligence. Different AI schools have different theories. So philosophers have the chance to have their impact on the engineering stuff. That's the reason why philosophers love AI. If philosophers say you need to biotechnology in this sense, well, they will be expelled by biologists. So, but the problem is the philosophical circle is even more chaotic than the AI circle. If you take the philosophical history as the bank of wisdom, you will have different ideas, and disputes and disagreements among philosophers should be bigger than expert disputes in any other human inquiry. That's the feature of philosophy, okay? And the worst thing is philosophy is not a science. You cannot have some experimental methods to decide which philosophical idea is better than others, okay? So people will say, no, in case that we cannot do experiments in philosophy, but how does philosophy evolve, okay? Definitely, philosophy has been evolving, but the problem is how. There are two ways. The first looks more rational, and the second way looks less rational. The more rational way is philosophers will do arguments. So this is something very comparable to AI. When we say doing arguments, we will think about maybe it is a theorem proving machine or something like that. If you believe that argument is nothing but a process of proving theorems, you need axioms first. And you have some set of logical rules, but where do the axioms come from? Okay, people will say from intuition. But where do intuition mean? Just some commonsensical ideas. Okay, so in most part of the analytical philosophy, philosophical arguments is nothing but the common sense plus logic. It looks like an expert system. Okay, you need some axioms fed to the systems representing some common sense in a certain sphere of human life, and the system has some kind of influential rules to deal with in order to yield some useful outputs. Sometimes we will not use logic, but a probability theory. So the comparability between the two, I think should be focused on the law of intuition, The intuition plays a double role here. The first role is intuition will provide some axioms, okay, some things that do not needing to be proved. Another role is intuition can check the validity of the output, okay. If the system has sent out a product which looks entirely counterintuitive, people would not like to accept it. Okay, I think AI will do the same thing. For example, if you want to design a machine which can do a production, the productive product should be intuitively acceptable. If it looks too weird, you will say, oh, no, not the case. We should redesign the system. Okay, here people's intuition plays a role. It looks like a judge. So this is a rational aspect of the evolution of philosophy. Okay, but there is a irrational aspect. I just borrowed the words from General MacArthur. He said, "Vitalian never die, but they would fade away." But in philosophy, we will say the similar thing. In older theory never die, but they will fade away. We do not use direct proof to refute an old theory. But with the time goes on, people will find that some old theory will lose its charm, and it will lose attraction or something like that. So look, somehow similar to fashion. So, for instance, behaviorism. Behaviorism, both as a psychological and a philosophical movement, has faded away, but maybe still alive in a sense. And around the 30s, 40s, and 50s, there are famous people who believe that behaviorism is the only right way for doing scientific inquiries into minds. Psychologists include Skinner and Watson, and philosophers like Lyell. Okay, but now it has faded away. Okay, it has faded away due to some rational reasons and also due to some irrational ones. For example, people criticize Lyell's idea. Lyell's idea is somehow similar to this. Okay, we cannot have it's very hard for us to have a right model of other minds because mental activity are not something visible. In order to do mind theory scientifically, what we need to focus on is just their behaviors. So his suggestion or his proposal is we need to have a philosophical framework in which we can systematically translate every sentence concerning or containing psychological verb into new sentences without these psychological verbs. A very easy case is if you want to translate this sentence, Tom believes that it's going to rain in Beijing. We have a psychological verb believes here, and it represents Tom's mental activity. But we do not like that verb. In a new sentence, we will say something different. We will say, John puts on his raincoat, he closed the door, closed the window, he takes his umbrella and something else. Okay? It is some outputs, behavioral outputs correlated to the belief that he believes that it's going to rain. But we do not need to characterize the belief itself. Just to characterize those behaviors would be enough. But problem is, it is very related to Bern's previous suggestion concerning how to model the inner state of another person in a OpenCog system, something like that. The problem is, from a philosophical point of view, it would be very hard to characterize one's inner activity only by doing that. Think about this. Some philosophers criticized Lyell in this way. Okay, you say that the belief that I believe that it's going to rain can be mapped onto a series of behavior sentence. Okay, but the problem is there is assumption. The assumption is I want to keep myself dry. Okay, but how to characterize that? If you want to characterize that, you need a further behavior sentence, and if you want to do that, you would have left another mental state to be characterize it. And that would force us into infinite regress. So people will believe that behavior sentence characterizing would be easier, but it seems that it should be harder. And that's the reason why I personally believe that we need to establish the mental model of other persons first. It looks harder, first of all, but finally you will find that you will get more bonus from that. This is my idea. But in the history, that strain, the behaviorism has faded away also due to other reasons, because people find that it is not so fashionable, that is the original aspect of the evolution. For example, the cognitive turn, people find that the cognitive computational mind of that is more interesting, especially due to Chomsky's contribution. Okay, this is what we have known. Okay. Of course, the behaviorism still has a major impact on NLP, natural language processing. I think we are all very familiar with the Turing test idea. Okay, we just think about the behaviors of the output side of the chat box. Okay. We also know the Joseph Weizenbaum's Alice chat box. Alice chat box is not designed to chat with a normal person. It is designed to chat with a psychologically sick man. So I think this is a very smart strategy, but it avoids the real hard problem. Just because psychologically sick man, he cannot check the consistency of another bird's conversation. Okay? He has no ability to check another bird's mental states. In this way, a machine should be easier for a machine to fool a psychologically ill-sick person than a normal person. So I think Elisa chatbox is a very smart idea, but it eludes the real problem. Okay, I'm just talking, so this is an open question. I'm not sure whether Eric chatbox is still on this box, on this line. I found it is more complicated, but Era system looks like just intimate the behaviors of the person who is engaged in the discussion without trying to model in the mind. So this is one. I just give you this the first example, the relationship between philosophy and AI. Okay, there are other examples. Another is external semantics. It is well illustrated in Wittgenstein's early book, Tractatus Logico Philosophicus. We simply say Tractatus. And it was criticized by later Wittgenstein himself, because Wittgenstein established two theories. The first theory is in Tractatus, the second theory refuting the Tractatus. The basic idea, I think, is very commonsensical. Okay, the first thing is the pictorial theory of Tractatus. He believes that maybe we have a web of conceptual nodes connecting to each other. Each node he called a name representing external object in the world. And if you connect different nodes into propositions, okay, they will correspond to some state of affairs in the world. And atomic proposition will correspond to atomic fact. And molecular proposition will correspond to molecular things. I think this thought is something we are very familiar in the AI construction. Another is logical atomism. Just in the PLM system, we have some atoms. Atoms in philosophy just means something cannot be analyzed into more elementary components. And Wittgenstein has a similar idea. He believes that there should be some logical atoms, and you cannot analyze them. And by connecting those logical atoms, you can contribute something. But one difference between Wittgenstein and the PLN is, in PLN, the link between the two inheritance links, something like that, they are atoms. And Wittgenstein did not say that. Okay, it just says that the nodes are atoms. It does not say links are atoms. But the basic idea, I think, is the same. The problem, the interesting is track titles seem to have faded away, at least from the perspective of late Wittgenstein. Late Wittgenstein found that he does not like the theory any longer, no longer like that. So he put forward another theory, that is language game theory, which is quite different from the former. So we have some instances to illustrate, AI instances to illustrate early Wittgenstein's idea. I think the most typical case favored by philosophers in the Terry Winograd, how to read it, Schidlu or something like that. Schidlu system. I think this is very classical in 1970s. Of course, it is too old, but philosophers love that because it looks like the prototype of different block world system. It looks like the grandfather of everything. Okay, why philosophers like Wittgenstein would have a philosophical worry about that? His worry is not everything represented by words can be defined as nodes mapped onto external objects. Okay, of course you can represent every word in natural language as a node. That's no problem, but a node does not mean its semantic content should be decided by something external to the web. When did Wittgenstein realize the problem of his early system? I think around his POW time. He joined the Austrian army during the First World War and caught by Italian army as a POW. And there he met some Italian friends. One of his Italian friends, whose name is Traffa, asked Wittgenstein a question just collected to his Tractatus book. He asked him, well, you believe that everything has a logical form. I just do a gesture. You know, Italian will have very rich gesture. It's something like that. A very strange gesture. He asked him, what does that mean? Could you find the large form of that blue? That Wittgenstein was shocked by that problem. Okay, if you want to know the gesture of something, you simply cannot regard it as a pure physical behavior. It's very hard. Of course, you can define it, but even if you view of course, it has a physical element or behavioral element in it. But you need to map that behavioral element onto something which is not physical. It looks like you should need to define the semantic content of a gesture in a web construction, and its content is not decided by some external objects, but by the topological structure of the web itself. Okay, that is the internalist approach to semantic content. So I believe that in Wittgenstein's late theory, his language game theory, his suggestion looks that we need to have a web. And in which web, of course we have different nodes. Okay, the outlook looks like the previous one, but the philosophical significance is entirely different. The semantic content of every node is decided by its topological status in the web construction. Okay, in this way, NARS is more Wittgenstein-like in this science, because in NARS, the intention and the extension of the one node is decided by the correlation between this node and the other nodes. You should observe how this node is connected to others, and to observe the direction of the inheritance link, then you can fix the meaning of something. Just like if you want to play a chess in a chess game, you need to define the chess law in the web construction of all chesses, not by something external to chess. Well, of course, somebody would ask the question, that internalist picture will make embodiment something harder, just because internalism makes something just defined within the website. But embodiment requires something bridging the gap between the inner representation world and the outside world. Okay, this is an open question, but I need to save time to turn to the next. So the second example is Wittgenstein, the early and the late Wittgenstein and the AI. And another example is Leibniz, okay? Leibniz believes that there should be an ideal language, that such a language composed by linguistic entities clearly representing ideas. So his idea is somehow different from the Schindler idea, the block word idea. Because in Schindler idea, if you define a block word, the meaning of the block word derives from the real block in the block word. Okay, it should overact the two sides. But according to Leibniz, such an ideal language, it will only contain linguistic entities representing ideas, and ideas something innately fixed in our mind. Okay, not something external. Another thing is rules to implement those ideas should be mechanically computable. It will look very fashionable. It's hard to believe that it was said by Leibniz, died so many years ago. Okay, so according to Leibniz, what does understanding mean? Just means a mapping job from the natural language to this innately fixed idea language. Okay, so I think this idea has predicted what nowadays AI would do.
Did Leibniz ever attempt to make this ideal language?
Well, sorry again.
Did Leibniz try to make the ideal, the universal characteristic?
So far, I'm not a Leibniz aspect. My knowledge about Leibniz is limited. So far as I know, he has an idea, but the elaboration of the idea language is something beyond his personal.
I read that part of Leibniz fairly carefully. Largely, this was described in a bunch of letters he wrote to other people, actually. And he called it the universal characteristic. And the idea of this language was sort of wrapped up with the early idea of what we now call Boolean logic, and what we now call probability theory. So it was all kind of one thing in his mind. Like he had the idea of representing concepts as some kind of terms or atoms. He had the idea of and or and not operations, which he derived from the I Ching originally.
Yes.
He had the idea of uncertainties, which were basically probabilistic, being attached to things. And he wrote out like a few simple examples of what if this concept were with this token, that concept were with that token. Then he wrote out what we refer to as Boolean logic expressions involving concepts. And then he thought that we should basically have some kind of team of a huge number of people whose job was kind of like Psychorp, right? He wanted to start Psychorp 500 years ago. We should have a large team of people who were going through and just representing human knowledge in simple terms and in logical combinations, and then they'd be done. Then we'd have everything represented in the language of thought, which was a quite forward-thinking idea, which he
slightly ahead of his time.
Yeah. I mean, it's a bad idea, but it's a very advanced bad idea to be having.
Yes.
So I guess we can count it as a good idea in some sense. But he failed to convince his wealthy patrons to invest their money in this project, and it didn't get off the ground.
Oh, okay. Thank you. Okay, so there is a couple of instances. We talked about, maybe Bern also talked about yesterday, that is the Interlingua project. So far as I know, it is run by Margaret Masterman. Of course, it belongs to history already. The basic idea is you have the source language, for example, is Spanish. That is something that we do not know. Suppose we do not speak Spanish, that's Gusta. And you have the target language. You need the system to map the source language onto the tagged language. So you need an interlingua. So we have the very, very basic logical analysis of that. That means what do the Gusta mean? Gusta mean is cause X be pleased by Y or something like that. So it basically means like, okay. But the problem is the interlingua system interlingual representation system should be very powerful for representing every possible natural language. It looks not flexible enough. Now I think maybe the interlingual approach now is replaced by, so far as I know, the transfer-based machine translation. Okay, it replaced by that. I'm not sure, but so far I don't know.
There are plenty of companies out there with a hybrid approach. I mean, there are companies doing an
I will talk about later.
Yeah, there are companies doing interlingual approach. So.
Yes. Maybe you will include the interlingual approach into a hybrid system. So I will talk about that. The transfer-based machine translation is more inspired by, I think, Chomsky rather than Leibniz. Okay, the basic idea is the superficial grammatical structure of natural language is not trustable. You need to give a further analysis of it to relieve its real structure, something like that. For example, the source language is Maria mi gusta. Syntactic analysis will give the first gusta mi Maria, but this is not deep enough. Sorry. Then we will have gusta subject argument to MP. Then that sentence will have a deeper understanding. Then on the basis of that, you would have chance to translate the SL to the target language. This is just illustration, very easy illustration. The real case should be more complicated than that. So from the philosophical point of view, there is a centuries-long debate between empiricism and rationalism. Okay, big empiricists include John Locke, George Berkeley, David Hume. Rationalists include René Descartes, Spinoza, and Leibniz of that kind. So this it is something, the debate in the philosophical circle predict the debate between statistics-based approach and a rule-based approach. So it is something very interesting. There is a mirror relationship between the two. And most rationalists, they would like a rule-based approach. They believe that our human cognitive system were innately equipped with those kind of rules to do the inference. But the statistics-based approach philosophers like David Hume, he did not like that idea. He believes that that's just an illusion. Okay, if you have a large data, you just do data mining, then you will find some regulations out of those data. For example, those output concerning causality. So a Bayesian approach may be helpful in updating what empiricists did believe in their times. Okay, so according to maybe IBM's candidate system, according to their proposal, an idealized translation is nothing but any mapping job which can make the value of the following formula approach to 1. Okay, the formula is probability of the target expression giving the source expression. Okay, but in order to compute this, you need to compute a lot of things. The system should try every candidate target expression and hence compute the result of the foregoing formula. And finally select the most qualified guy out of the candidate pool. What you need is a very large database to do computation. Okay. So similarly, like Immanuel Kant, in the philosophical tradition, he believes that both empiricism and rationalism may be wrong in going extremes. What Kant wants to do is he wants to combine empiricism and rationalism. Kant's theory is very complicated. I just rephrase it in an AI way or cognitive way. He just wants to make the bottom-up and top-down approach. This is not my first idea. The first idea to implement Kant in this way is put forward by Hofstadter and David Chalmers. When they designed the copycat program, they believe that copycat the program intended to do analogy. They believe that in order to do analogy, you need both ways, bottom up and top down. And they believe that this idea is from Kant, and he used that idea. So I will say something more about Kant now. Because Kant believes that our cognitive capacities can be divided into two groups. The first is the capacity for having sensations and perceptions, lower level cognition. Another is the mental capacity for having a semantic network. Of course, he will not use that word, but meaning is the same. Okay, it looks like what Kant is now, he joined the AGI society. What Kant would do in designing AGI robot, he would look like, maybe he would like an OpenCog approach. He would say we will use a lower level pattern recognition system like Destin to model our human capacity for doing perception. Okay, but that's not enough. We need a top-down approach to have a semantic network. Maybe some of you know that Kant has a theory of categories. Okay, for example, causality is one form of category. That category would help you to correlate one event as cause with another event as effect. And the substance is another category. And category, if we reinterpret category in the current terminology, it means that just means the logical features of different inheritance relationship for example, in the NLP network. Maybe this is what because there are different links with different logical properties. Maybe Kant would say they belong to different categories. He used a category in a weird way, different from other people. Other people will say category just a big type. But what he does mean is the form of judgment. So I believe that category in Kant's context just means the logical property of a link in the Weber construction. Okay.
So would Kant believe that a machine could sense the nominal rather than phenomenal aspect of the world?
Well, this is, I think what I'm talking about is if we transfer Kant's idea about cognitive architecture into AI, what we can achieve. But whether machine can do this job is another philosophical issue. I think it's a metaphysical problem. And I do not know whether Kant would say yes and no, because Kant's idea about the man-body problem is very ambiguous.
Yeah.
He just says this is a metaphysical problem, we do not care about that. So
Right.
we have some flexibility in this sense. Yeah. We just borrow ideas what we want to borrow. Okay. And okay. So instance in NLP, of course I think OpenCog is instance, but if we talk natural language processing, so far as I know, Nirenberg and Fred Durkin, they have a multi-engine machine translation approach. Just like Ben has mentioned minutes ago, maybe we have different machines. One based on statics, one based on rules, and one based on instances or examples. I will come to the instance-based approach in a couple minutes. Okay, there are different engines, and maybe the three engines will deal with handle the same source text, and they will send out three candidate target texts. Then a higher order evaluator will select out the best one. Okay, people believe that if we can combine everything together and let it work together, maybe we can make the quality of the translation higher. The philosophical warrior, there is a philosophical warrior. As the criticism of Kant made by Hegel has shown, the integration would be a big problem for any hybrid approach. Hegel said a lot of bad words concerning Kant, and many of them are very puzzling, very confusing, because Hegel is basically a puzzling guy. But so far as I can understand, if we transfer what's said in context of cognition, let's say, well, Kant, you have a dozen of categories and listed separately. but we do not know the mutual relationship among those categories. That means inheritance, something like that. Hegel say we need something to see how one kind of form of judgment derived from another, in order to make the whole picture more integrated. Hegel is a person crazily fond of unity. He hates anything which will challenge unity. Okay, so Hegel's proposal is something like that. And he has a book on logic. Okay, he has a logic book, but it is not traditional logic. It is his own logic. In his logic, he believes that among all of the categories, Sein is the most primitive. And Sein is just a German word for to be, okay? And his next step work is to derive other words like causality or something like that out of them. This is a very ambitious work. He just want to think that those links, the types of links, they are originally they are something stand from the same type of link. There are some family resemblance among all of the links. You simply cannot do counsel job to separate them. Maybe in this way I found Pace analysis somehow similar to Hegel's logic book, because analysis system layer by layer. We have the NAR 0 system for a layer first, then we have NARS one layer, and the second layer is defined in terms of the first layer. You need to have the first layer first, then you have the second. Okay, the second one cannot be separated from the first one. The same is that all of the logical relationships in the second layer can be seen as something derived from the previous layer. So it looks like a modern version of Hegel's logic.
No, I mean, there have been attempts to make actual formal logic versions of dialectical logic, which are very different than NARS, actually, right? Because the basic operation in a Hegelian logic is like the thesis, antithesis, synthesis. Which is pretty different than...
Yeah, yes, quite different. When I think about that, Hegel's logic is basically in the tradition of term logic. His logic was, of course, he talked about synthesis, antithesis, and synthesis.
It is a term logic, but the basic inference rule is different than the...
Oh, yes, different. It should be different, because Pei has an idea that Hegel cannot live with.
But some people have made a formal logic.
Yeah, I know that.
Of dialectical logic, right?
I know that. It was fashionable even in China, because...
Probably, yeah. I saw that in Russia, where it's also fashionable.
Yeah. I mean,
it's a communist AI system.
Yeah, a communist AI system. But I believe that Hegel's idea of something like that. I do not like a very stupid representation of Hegel's idea. Hegel's idea is something like that. He sometimes says this: there is subject and there is the predicate. Okay, the subject and predicate. The Hegel's dialectical logic will add a sentence. Say, if we say S is P, maybe it means nothing but P is S. He will say that. And S is P is the thesis, and the P is S is the antithesis. It looks very weird. If you say men are rational animals, what in this sense that mean rational animals are men? How to interpret it rationally? I think Hegel means something different. If we use NARS logic, we can interpret it in this way. If you can infer from this direction, of course you can infer from that direction. But with different truth values in the website. Okay. So Hegel, what Hegel would say? Well, in one context, S is P to some degree. But you should remember that in other contexts, P is also S, but to another degree. And people would forget the second. Okay, I will remind you the second. Hegel would say that. Then Hegel would say something more confusing. He would say that, well, why we can say that S is P? and also say that P is S. Maybe there is a higher order concept, higher order concept that would contain P and S as two aspects. So we have another P star concept. But if we reinterpret it in another way, maybe we would say there is a higher order concept which is the compound term. Okay, maybe we can combine S and P, and that compound term would facilitate some influence in certain domains. In this way, maybe we can combine Hegel with Nernst a bit, and without invoking the communist style of representing. That has a very bad reputation, I think. Now we turn to the favorite part, Confucius. My favorite part. Well, we need to talk about him in a way as if he were a newcomer of AGI society. Okay, we need to forget his historical surroundings because those stuff are irrelevant. But what Confucius would say if he knows these AGI stuff? I do not believe that he would like rule-based approach. There are some evidence for saying that he never defines concepts or given axioms. Gives axioms. For instance, he never defines the core idea of his book. That is benevolence. Okay, in Chinese we say that is ren. It's very hard to translate ren. I think most people translate benevolence, and he will not give the benevolence axioms. And if you would give benevolence axioms, what you would do? You would use Asimov's 3 laws of robotics. Okay, if you want to say we can put benevolence in the axioms, maybe this is the first law of robotics. The robotics is we should do something in a way in accordance with the principle of benevolence if and only if such conditions are satisfied. This is the first law of the Chinese version of Asimov's law. If孔子or Confucius did that way, he would do that. But in fact, he did not like that. Nor would he like statistics or large-scale data mining. I misspelled the word. He is an editor which would delete files. So if you are a data mining expert, you would prefer large database. You will not delete files. You will try to collect more data as much as possible. But what孔子or Confucius found of? He found of deleting files. I will give you an example. He has a book of songs that is an early collection of Chinese poems. That collection contains 305 poems. Okay, I think there should be more than 3 and 5 poems circulated in spring out time or even in the early Zhou dynasty. But孔子deliberately choose a small example of it. So he does not like a large example. Okay, he does not like large example space. Instead, he just a storyteller. The story and not rules on the one hand, not sufficient for forming big example space on the other. But what story mean here? Maybe we can use some ideas from linguistic cognitive psychology. The Losch's idea, maybe there is a prototype effect. Okay, some example point in the example space are more salient than others. Due to their salience, we only need to pick out those salient points, ignoring the rest of them. It seems that Losch is interpreting what孔子has done. But if we talk about MT, machine translation, maybe instance or example or prototype-based approach is mostly put forward by Japanese AI scientist Makoto Nagao. He believes that there should be a dual lingua mapping samples given to the system. Okay, you just give the system such kind of things. Since I'm not a Japanese speaker, I replace all of the Japanese sentences by Chinese sentences because the fact is the same. Even if you do not know Chinese, but you just read the four linguas mapping samples, you still can figure out the meaning of every individual Chinese characters, even you do not know, okay? Because you can find that the first sentence and second sentence, I feel dizzy and I feel hungry. Okay, you'll find that the subject I looks the same. And the Chinese sentence, the subject, the first character looks the same too. So the logical inference should be what means I. Okay, the first character means I. And so forth, you can do something like that. Okay, and the system is expected to figure out the mapping relationships on the word level. And once this is done, it will try to figure out the grammatical structure of the Chinese language. Okay. So, but in order to do that, you need to have two different things at hand. The first is a large past corpus. For example, Japanese, Chinese, English, Chinese, English, Japanese, something like. Corpus is very important. And an inferential machine, in order to do a knowledge. So far as I know, Makoto Nago, he also developed the first or maybe the biggest the English-Japanese duolingual corpus in order to do that. In this way, it is somehow right from Confucius' the original idea, because Confucius did not like large space, sample space. But in order to do Makoto Nagao's type of work, you need that kind of large corpus. Okay, finally, I will have some brainstorm ideas concerning LLP. Because we are doing natural language processing or understanding in the context of AGI, not in the context of the traditional AI. And in traditional AI, the goal is very low. We only need to get the machine do translation job, which looks basically good or barely good. That's enough. Okay, I think no serious traditional MT scientist would ask the machine to translate Nobel Prize winner Moyen's novel into English, because novels are too challenging. They will just ask them to translate, for example, some scientific report, some very easy thing. Okay, but if we do AGI, we have higher goals. Maybe we need a full-fledged intelligence for doing that. We really need somebody to translate some poems from one language to another in a sensible way. Okay, at least at the human level. This is the ambition that only AGI has. But in order to do that, what we need to do, besides the traditional approach, my first idea is embodiment is something very important. Embodiment is not a discrete module. Besides the NLP module, it should cooperate with each other on different levels. Okay. For example, I feel hungry. You need to feel hungry. You know that. Suppose I'm a robot. I do not have biological structure, but I still know that I need some battery to feed myself. Okay. I also have my body made by silicon. Okay. So I have my conception of hungry, and I can do some analogy between the robotics hungry and the human hungry. So I get more meaning about that. And when I say hungry, I have some related emotions concerning hungry. Maybe I'm in anger, I'm in anxiety, or something like that. Those emotions would help me to read the text better. And to evoke other semantic nodes in the website, then to make the resulted translation text more flexible. Okay, so embodiment is something very, very important. I will talk about a crazy idea. That is, the most challenging thing is not hungry. We can easily model the feeling of hungry in robotics. The most challenging thing is sex. Okay, we can model sex in some way, but it should be quite different from robotics sex and human sex. Why it is important? If we want to translate literally things, a lot of things is about male-female love. A lot of human emotions are correlated with that, not about concerning we need to feed ourselves, but we should have a mate.
So you don't think young children have a full enough array of emotions, for example?
Yeah, of course it has of course it have emotions, but compared with adults, since they do not have that kind of direction, it is hard to say full-fledged. It lacks some dimensions.
They actually don't. I can't remember the details. But the more complicated emotions and feelings sort of evolve through ages 2 and 3 and 4 and stuff. And jealousy and stuff.
Sure, but before puberty.
But there is a big debate between me and one of my friends who studied Buddhism. He said that AGI is never impossible. I said, why? His argument looks very, very strange. Robots cannot have sex as human beings do. So there are some emotions concerning with sex, and if you disregard that, you will lose a lot of things.
So if you make a sex robot, then it can be truly intelligent?
Well, what does a sex robot mean? You can make a sex robot to satisfy human users' desires, but what I mean is a robot with his inner model of sex desires. So what kind of robotic sex desire would like
but
to?
Why is it special? I mean, if you could make a robot that has qualia and enjoys walking down the street or solving an equation, if you gave that robot sex organs, presumably that robot could also enjoy having sex. I mean, why isn't that just qualia plus a specific kind of physical experience?
Well, it is the first issue is the qualia problem. It is I want to allude to this problem. It looks too puzzling. Some philosophers like David Chalmers, he doesn't believe.
But what is the sex problem apart from the qualia problem? That's what I'm not understanding. What is special about sex qualia as opposed to other ones?
Because from the perspective of evolutionary psychology, sex is something very deep. It correlates with other kind of things. It believes that all of our
But so is eating and breathing, right? Breathing is very deep.
Yes.
And if you look in Eastern religion, breathing has a foundational role, right? The Hindus and Buddhists think that the prana, the breath, is the base of life. So why is it sex and not breathing, which is fundamental, for example?
Well, it's let me think about that. Okay, we will talk about it later. Yeah.
Okay.
So this is one thing, but the basic idea is embodiment is important. I think this is something that we can agree with. Another is high quality machine translation also requires the system's understanding of other minds. And why? Because when I'm reading a novel, I should believe that this novel is written by another people. It is not written by a monkey, a human being with a full range of emotions, of something like that. I need to think about what he would do. If we have some practice of doing translation, human level translation, you need to think about what he would think about. Then you will find the best way to do the translation. Okay, otherwise the resulted translation cannot be good. But in order to do that, you need to do analogy between his mental inference and your mental inference. And in order to do that kind of inference, you need to have self-knowledge first. That means you should know your way of doing inference first. So you should presuppose the first layer, self-knowledge, the second, the mental capacity to grasping other minds by doing analogy between your mind and his ego. And the third level is to implement a procedure of doing machine translation. Okay, I don't think the traditional MT is being done in this tradition. They will say that makes things too complicated. But if we want to make the system more flexible, maybe we will try this more complicated route map. Okay, so that is, from my perspective, I believe that an AGI inspired by the machine translation approach
should be different from the traditional machine translation approach. So, okay, this is the end. Thank you. No, some questions and okay.
Yeah, so I have another question about Chinese philosophy. So you told us what Confucius thinks about AGI. So what about Taoism? What does Lao Tse think about AGI?
Oh, that's a more challenging problem because I'm not sure about that because I favor Confucius more than Lao Tzu because AGI is in some sense it still continues the traditional AI in the sense that they believe a computational model of mind is right. Okay, you have a mechanical picture of how mind works. This is the basic philosophical assumption. Okay, and I think Confucius he keeps neutral to that idea. He can say nothing about that. But Lao Tzu, Zhuangzi, both guys, they do not like anything concerning engineering and technology. Then they believe that something mechanical cannot be good.
They would seem to be in favor of like Andy Clark's extended mind hypothesis.
Yeah, that's right. They believe that there is some continuity between the cognitive architecture and the environment, and you are not really different from the environment. This is the best their idea. But according to Confucius, there should be a boundary between the two, but not due to some philosophical reason, but due to some ethical reason, because you need to have moral agents to be responsible for something. If you do not have the boundary between your body and other body, how can responsibility be distributed to individuals? That will destroy the morality. So because he basically does ethics, so he would have that kind of idea. But so far, Mozi is concerned. Now, I'm not expert in Mozi too. I basically do Western philosophy. Mozi, he favors engineering. He favors technology. No doubt, he is such kind of person. I believe that he loves logic too. Okay, there are a lot of contemporary Chinese philosophers want to reconstruct Mozi's logic. But I do not know whether he has a full-fledged theory about human cognitive architecture. I don't know whether he has that. Chinese people, traditionally speaking, do not care about that kind of questions.
Yeah. Sure.
Maybe
but they cared about questions of self and will, which are questions about how human cognition works, and they sort of hypothesize that we don't need the self in the ordinary sense, and that we don't need to view ourselves as causing or willing our actions, but in some sense we should just relax those things and let the universe guide our actions. And I wonder how does that fit with the AI models of will and self-modeling and so forth.
I'm thinking about that. Rodney, maybe it is more era-like. You need to observe the environment, and the rules are not based inside the cognitive system, but based in the environment itself. In this way, it looks similar to Chinese idea that there should be some harmony or unity between human beings and heavens. But there is still a slight difference. If I do Confucian philosophy, not other school of philosophy, Confucius also says that you need to be more active to understand the meanings of Tian, of heaven. Okay, you are not purely passive or passive. So it seems that there is already maybe a potential conceptual network in the environment. Okay, the cognitive system need to learn that bit of information bit by bit, then to enlarge it, to enrich it, to revise it. So Kongzi himself has a famous saying to talk about the evolution of human individual cognition. He said that at the age of 20, I can know this. At the age of 30, I can know more. And at the age of 70, I can already achieve the harmony between the heaven of that, between that. I already guessed that. It's a long procedure of learning. So I think it is not as simple as Laudani proposed.
Interesting.
Awesome.
Question for you. Just one. Do you believe that language is central to AI?
Central to what?
Central to AI.
Central to AI. Yeah. It will depend on what kind of language we will think about. From philosophical point of view, we have two kinds of language. One is a natural language, Spanish, French, Chinese. Another is an innate language or language of thought proposed by Jerry Fodor. But there is still a similar thing. Just for example, NLP is, I believe, that not a natural language, but an innate language or a language of thought. It still has some grammars, some semantic things. So if I say I do not distinguish between the two, I just say language in the broader sense, my answer would be yes. Although I know that maybe it's quite different from the AI perspective, just because there is some basic philosophical intuition for supporting this kind of idea. Okay, just like for example, what does representation mean? If we say language, there should be representations. Okay, and if we say some sub-symbolic approach to cognition, we'll say there are no representations. So this is a problem concerning the law that representations should play in cognition. And there are many facilities for having representations than not. For example, representation literally just means something which can represent something else. And the real world is too chaotic, I think. It is too terrible. Well, think about, but I had to raise the question, if we live in a liquid world, not on the planet something, liquid world on another planet, what would happen if there is an intelligent system which can handle the environment? My response is it still should some mental instruments or devices to divide the continuous things into blocks.
Why do you think that?
There is another way to do that. For example, you need, if you want to form some, of course you gave some examples about the whales and the dolphins.
You can do Fourier analysis, wavelet analysis. There's many ways of, you may decompose things as like continuous weighted combinations of other continuous things. Right?
But they're just a gesture. We do not really know how the dolphin language works. Really?
No, we don't. And dolphins are also solid objects. Dolphins are not like gas clouds living in Jupiter or something, right?
Yeah, they're just a gas.
In fact, dolphins descended from land animals originally.
Yes, that's right.
So that's not that far out an example either. If you really had like a giant amoeba living out in a gaseous or purely liquid environment, it's not clear that...
Yes, we still have room for doing conjecture. So my philosophical intuition is if you want to transmit information from one side to another, you want to keep that information stable enough, and it should be duplicated or something like that. If it is just wave-like things without very clear boundaries, the problem is, well, you can hardly fix that. We Chinese language already have that problem. We know in our Chinese language, one sound will correspond to different meanings. But how can we solve the problem? We should write it down.
But the brain duplicates information all over the place. It's very, very redundant, actually.
Well, I don't know. For example, I just give you the words of, I think not every American, nearly most American cannot sing the American national song. Okay? I think it's very challenging. It's a very difficult song to sing compared with the national song of China. Okay? But many Chinese can recite the words, okay? of that sun. It's very easy for you to duplicate words, but to duplicate something continuous, it requires a kind of different technology or mental capacity. I think it would not be economically acceptable for the natural selection to favor that kind of system. I should natural selection system would just favor the current way of transmitting it. I don't just a philosophical conjecture. I do not
It
have.
really depends on the environment so much, because there's a lot of genetic drift along with fitness-driven selections.
So you're right, but I have a further observation. Maybe it looks weird. I really suspect that in that kind of environment, any intelligent system could have a chance to evolve. I just have a big worry about that. Because this is not a problem of AI, you need to ask some biochemistry experts. Maybe they will give some answers.
You know the science fiction novel Solaris by Stanislaw?
I don't know that.
Yes? So I mean, he posits an ocean on some alien planet which has amazingly complex patterns, and it responds to people in complex ways, in this case causing them to hallucinate different things and so forth. So it's an extremely complex, adaptive, self-organizing system, and people try to communicate with it.
But
ultimately it's so different, they give up on trying to communicate and go home, because so it's intelligent in some sense. It's a very complex, adaptive, self-organizing thing, but it's intelligent in such a different sense from us that we can't even build a bridge to it, which is an interesting hypothesis.
Well, what I'm more interested in is in that fiction. What about those alien people's body construction? Do they have fixed shape of body? That is very important. If they have fixed shape of body, they are solid things, okay?
Right, and
they are the starting point for building blocks.
In Lem's hypothesis, it was like the whole ocean surrounding the planet that was in some sense intelligent, and the various hurricanes and waves and so forth had extremely complex adaptive patterns.
But we don't have fixed shapes bodies.
Oh no!
I'm changing my shape.
No. What I'm not mean is
if I lose an arm, you know.
Yeah, I'm not talking about what I mean is every intelligent person can tell the boundary between your body and the environment. Even if you change the shape of your body, you still know this is not a body, this is your body. This is important. Just for example, on the same.
But then the question becomes very different, because then you're saying, are there intelligences that are embodied somehow in a body that doesn't have a clear boundary? That's a very strange.
Oh, I think it's a related
question.
That is a related question. Why it looks different, but still related? Because I believe that from the evolutionary perspective, intelligence is just a mental capacity to keep you adaptive to the environment, to sustain your body. So it has assumed that the boundary should exist.
But to point to something and say that it's intelligent, you'd have to be able to identify some sort of boundary.
Yeah.
Maybe the boundary for some beings is more clear than others, but at least if it's a self-sustaining entity, then you could point to the API for its energy absorption and release. So at least you have some part of the API defined, right? So in any case, I think you're going to end up with a tautology there, because you're going to end up having to say, well, a body is necessary because otherwise there wouldn't be a boundary with this thing to its environment, and then you would have to admit that the environment is intelligent. But what is the environment? Then you have to define what's an environment, and so on. And the environment then is some subset of some other larger, reality. So,
in order to avoid infinite regress, we will just say environment is something negative not the part of the current cognitive or something biological structure. It not belong to that. That would be easy way to do this. Yes, I just think about from the micro level, we have cells, and the cells have cell walls to distinguish the inside world of the cell from the outside things. Okay, this is the primitive form of life, and we found that our whole human body is just the recursive construction of the cells. So it looks that it's a most natural way to do that. I simply cannot think about other.
I have a couple of questions on your Wittgenstein slides. I think primarily the philosophers of past are not that useful, except maybe for the very big questions, like do we actually believe that there are some unknown physical or metaphysical forces that have to be explained in order to explain general intelligence? I think pretty much probably everyone in this room agrees with, at least to pretty far along level to the idea that we can implement an AGI, but we may have different sort of boundaries there at the edge of sort of, okay, once you get a really smart system, you know, does it still lack some qualia, some experience, or not? Are they zombies, or can we figure out that part? For example, that would be, to me, that's one of the boundaries where I go, okay, well now you're in, you know, philosophy land, and you can philosophize all you want about that. But my opinion is that the mechanics of intelligence, by and large, in all major aspects, probably all aspects, are mechanizable. They are biological processes, and they certainly rely on very ill-understood self-organizing principles of matter. But you don't need probably metaphysics to explain intelligence. Now, as for qualia, I don't know. But I think actually building an AGI is a very good way, or at least one of the ways in which we can explore that question. I think, you know, Wittgenstein had some very good points about the simplistic version of the AI argument. And he had some very good points about sort of, if you want to go all the way and say, okay, well, the brain is a binary computer, and you should look for the zeros and ones. You know, that is like the ultimate simplicit version or interpretation of Turing's thesis. And I think he had some very good points about that. And you know, if you look at, for example, computer vision research, it's still very much, you know, well, you snap an image, you know, a picture of the world, you map it onto some database, and that's your response. And certainly, knowledge is much more complicated in human minds, and I think it's some part that we have to replicate in AGIs. And that's exactly the path we are taking with ERA. And your last point there about calling ERA the chatterbox bot era, I think, is a very wrong one. Because if there's any approach that I've seen so far that goes away from the simplicity, the simplest version of the Turing thesis, it's error. And so, you know, I resent the use of chatterbot in that context. But anyway, the more important point is that if you look at sort of the majority of AI research and the constructionist approach, basically it's a simplistic version of the thinking is computation. And I think Wittgenstein probably would still maintain that in light of past history. But I have a suspicion that probably he would agree that ERA is a good step in some right direction.
Yeah. Yes, the first of all, I should say that I did not say that ERA is a chat box. What I did say that I'm not sure whether ERA is a chat box. So I'm not sure about that.
But you're right, though, in the intuition that it's not. I mean, it's very different.
ERA is a very inefficient chat box.
Exactly.
So far, Wittgenstein is concerned, yes. In Wittgenstein's 1930s, he had a good personal relationship with Alan Turing himself. Both guys, they are at Cambridge. They have chatted with each other. And in his manuscript about the foundation of mathematics, we found some evidence that he treated with Alan Turing's thesis or even other related things, even Gruder things in his manuscripts. But those manuscripts are very hard to understand. Evidence showed that he did not, Wittgenstein did not like the mechanical theory of mind. And some Wittgenstein experts want to say that. But I do not want to explore this direction because it will only interest Wittgenstein scholars, not the wide circle of people. I try to figure out some arguments put forward by Wittgenstein at that time. Wittgenstein said a lot of things against the computational model of mind or mechanical model of mind. And I found that none of them can work. I study Wittgenstein, but I do not like that part of Wittgenstein. I still believe that the mechanical mind theory will work. I personally, my own philosophical position is functionalism, and I believe that what is important for mental architecture is abstract functions, which can be multiply realized by different substrates. One might be biological, another might be silicon. In this way, AI can borrow ideas both from philosophy of mind and cognitive science and psychology to have an abstract model and find their way to interpret it in a Turing machine computable manner. In this way, this is my basic philosophical doctrine. I should say, so far this part is concerned, my thought is different from Wittgenstein. What overlaps with Wittgenstein is I preferred his language game thought. I believe that, maybe the semantic content of a semantic node should be determined within the web rather than something outside. Maybe you can add something outside, but you should find a holistic manner to treat semantic content.
Yeah, and I think that in the functional view, ERA is very close to actually what Wittgenstein was saying.
Yeah.
I'm not so sure that it maps in very many other ways.
Yeah, maybe. There is, for example, so far as I can remember, if you chat with human agent, suppose I'm a Robert, and I will follow what he said and have some conjecture out of what I have get. And I will check the validity of my conjecture in a wider context, just like to check the validity of mover chess in chess playing.
I think a lot of the mistakes that were done in the early 1900s in thinking about these things have to do with the fact that people slice out certain parts and ignore other parts.
Yeah.
For instance, in order to really get a decent picture of how an AI or an AGI should be made, you have to include goals, and these guys don't talk too much about goals at all.
Yeah.
So anyway, we'll leave it at that.
Yeah.
I guess we will have to stop here.
Yeah. Thank you. Thank you all. Yeah.
Thank you.
Yeah.
some more questions?